Okay, welcome back everyone. So in a previous video we learned that you can calculate force, or work rather, by taking force times displacement times the cosine of the angle between them. And what we talked about is that this is only true, this calculation that is, when the force is constant. Like near the surface of the Earth, gravity's fairly constant, so the force of gravity is pretty constant. But if you have a case where you have a spring, where the force of a spring is equal to some constant times the stretch x of the spring, well, and this is what we call the force constant, then it's not so much the case. And now we can make use of a pretty useful tool. We can just simply graph the force versus the displacement. And so for example, let's look at number 35 on page 171, which has a situation kind of like this. We have a distance measured off in meters and force in newtons that goes up by 10 per tick mark. And so we have a situation where the force increases steadily for the first 0.3 meters, and then for some weird reason it jumps up all the way like this for the last 0.1 or 10 centimeters. And what we need to do is find the work. Well, hopefully you notice that the area of this graph is the work done. Why? Because the area is the force times the displacement. So all we're going to do is divide this graph up into a couple triangles and a rectangle, and we're going to calculate area. So for this first triangle, we have a height of 20, we have a base of 0.3, so if we multiply those we would get 6, but it's a triangle, so it's 3. Now what kind of units should we have? Well, we have newtons times meters, which are joules. Okay, in the rectangle we have 0.1 times 20, or 2 joules, and in the last triangle we have 0.1 times 20 times a half, which I think is 1 joule, and if you add all of those up you get a total work of 6.0 joules. So the moral of the story is when you have a varying force, you simply plot it on a graph and you find the area. Very easy.